Hi students! Today we're going to talk about another super important chemistry topic, and that is polarity. What is polarity? Before we get to the chemistry definition, let's think about what the word itself means, just in regular English. When you hear polarity, you might think of something like the North Pole and the South Pole of the Earth. Or you might think of two people who are polar opposites. Both of these examples are describing something that has opposite ends. And we can describe polarity in chemistry very similarly. So a polar molecule is a molecule that has opposite ends. Okay, well, what does that mean? To understand that, we need to revisit different types of bonds. So before we talked about covalent bonds. Remember, a covalent bond is one where electrons are shared. So here is a molecule of water. In this water molecule, there are two electrons shared between this hydrogen and this oxygen, and two here. These are the covalent bonds. I used water as an example here because water is a polar molecule. What does that mean? It means it has opposite ends. Let's look at two examples to understand that a little bit better. Here's a water molecule. We can also use this little toy to represent a water molecule. See how it has one end, an oxygen end, and then it has a hydrogen end? Because water has different ends, we know that water must be polar. Let's compare water to another molecule, ethane, which I'm going to represent with this toy. See how there's no ends really to this? If I were to say this hydrogen here is the top, and then I flipped it around, well, which one is it? I have no way of knowing. But if I said, okay, let's say this oxygen is always the bottom, and I flip this around, I know that's still the bottom because it's still the oxygen side. So in this case, water is polar because it has different ends, but this ethane molecule we would say is nonpolar because it is essentially symmetrical. How does that tie back into this covalent bond idea? Well, remember, we've already figured out that water is polar because it has different ends. To put it more specifically, more chemically, what we would say is this oxygen atom is more electronegative. In other words, oxygen really loves electrons. And so what this oxygen is doing is it's pulling all of those electrons closer to the oxygen. So it would actually be more accurate to draw this molecule like this, with these shared electrons much closer to the oxygen. So remember, because electrons are negative, they have a negative charge, that means this end, the oxygen end of the water molecule, is going to be more negative because it has all those negative electrons. And then comparatively, the hydrogen ends are going to be more positive. Hey, poles, just like poles on a magnet, right? And so this is important. It's super important actually in biology because if we take another water molecule and we align them up, positive end to negative end, something special happens. They connect, and that's called a hydrogen bond, and we will learn about that in AP Bio.